Good afternoon, class. Today we are going to learn how to integrate technology and the engineering design process through challenge-based learning. In order to do that, we will be implementing a unit called Measuring Up. It will answer this essential question: why is accurate and precise measurement important?
What math will we be learning?
Along the way, we will learn math concepts such as measurement, conversions, scale factor, algebraic expressions, and spreadsheets.
When will I ever use this in real life?
Civil, mechanical, industrial, aerospace, medical, structural, and many other types of engineers use these concepts daily to design, build, maintain, and improve things such as structures, machines, devices, systems, materials, and processes. We will now watch a short video about the challenge that will be presented to you and the process you will use to find your solution. Challenge-based learning. Today's challenge is that you need to build a warehouse for your locker company. Your warehouse must have at least 5 frame windows, at least 2 frame doors, at least 1 frame loading dock, and all walls must be framed. Additional requirements include building a scale model of your warehouse, having a company logo on the side or somewhere on the warehouse, having a detailed budget, and a presentation for the finance company. Your company engineers include a wall engineer, a door engineer, a window engineer, and a sign engineer. You will all use 21st century skills such as collaboration, communication, critical thinking, and creativity. So what process does an engineer use to find a solution to a challenge? The engineering design process. Step 1 is to identify the problem. Step 2 is to identify any criteria and constraints. You can do this by collecting guiding questions that will help you along the way. Step 3 is to brainstorm possible solutions. Step 4 is to generate ideas and explore some possibilities. Step 5 is to select one of your approaches and build a prototype. Step 6 may take a few times, but you need to refine the prototype until you come to an agreed solution. Step 7 is your final solution. You will then take your final solution and communicate it to others. This is the engineering design process. The following are some student testimonials on how they feel about the engineering design.
I liked this project because it was a lot more hands-on and it was a lot more interesting and a lot easier to pay attention to compared to just, sitting there and, teacher talking away.
I think what I like most about the project is that we sort of had to work together and use measurements, and we had to communicate.
We all had to work together to figure out what we needed to do. One person had to make the exact size windows, other person had to make the exact size holes in the wall, and it made us all collaborate together.
I liked designing it.
I liked building it and putting it together.
I had a lot of fun joining the project. The most difficult part for me was trying to convince the kids that it was okay to fail, and because that's part of the engineering design process for them to refine their ideas. They wanted it to be perfect the first time, and it wasn't, and that really frustrated a lot of them. So there was a lot of stress in the room. The other part that was a big change was just letting go of some of that control that teachers sometimes feel like they need to have. So just letting the kids go with it and learn as they went and being a facilitator. It's a lot different than most of us are used to running our classroom. So it was a learning opportunity not only for my students but also for me. Thank you for watching the video. Please let me know if you have any further questions about the challenge or about the engineering design process you will be using to find your solution. Good luck! See
Games is funded by the National Science Foundation, grant number 11029990.